Now in this lecture we are going to recap the time and space complexity of all operations that we have learned till now on circle single linked list. The first operation is creation of circle single linked list. So here time and space complexity is constant because when we are creating a circle single linked list we have to create head and tail and first node, which takes constant time operation. Similarly, for space complexity we have to create only one node and two reference variables. So this is also a constant space complexity operation. So that's why the space complexity for creation of a circle single linked list takes O1 space complexity. Now the next operation is insertion. Now when we are inserting a node in circle single linked list, we have three cases. The first case is we are inserting a node at the beginning of circle single linked list, and the second case is we are inserting a node at the end of circle single linked list, and the third case is we are inserting a node at any given location in the circle single linked list. Now when we are inserting a node at the beginning of circle single linked list, in this case the time complexity is O1 because here we are just changing the references of head and last node's reference to point to this node over here. So this operation takes O1 time complexity, but when we are inserting a node at the end of circle single linked list, so in this case we have to loop through the circle single linked list until we find the node that is located before the last node, so that's why this loop will take O(n) time complexity. Now when we are inserting a node at any given location in the circle single linked list, in this case also we have to traverse through the circular single linked list until we find the specified location. So in the worst case, this might take O(n) time complexity. So that's why the insertion in time complexity, if we combine all these three cases together, takes O(n) time complexity. Now the space complexity is O1 because in this case we are just inserting one node to the circle single linked list. So that's why one node will take O1 space complexity. Now the next operation is searching operation. Now as we said before, when we are searching through circle single linked list, we are doing linear search. So linear search means that we are visiting each node of this circle single linked list and comparing with the value that we are looking for. If this is the value we are looking for or not, then we are continuing to the next node, then we are continuing to the next node until we reach the last node. Now in the worst case, if the node that we are looking for is located at the end of circle single linked list, in this case this will take O(n) time complexity. So that's why the time complexity for searching in the worst case is O(n). Now the space complexity is O1 because in this case we are just looping through the nodes and checking that if this is the node that we are looking for or not. So an additional space is not required over here. Now the next operation is traversing. Now when we are traversing through any given linked list, we are visiting all nodes of this linked list and printing out their value to the console. So if the number of nodes in the circle single linked list is n, so the time complexity will be O(n) because in this case we have to visit all nodes of circle single linked list. Now the space complexity is O1 because here one more time an additional space is not required, so we are just visiting the nodes and printing their values, so this is not space consuming operation. Now the next operation is deleting a node from a circle single linked list. Now when we are deleting a node from a circle single linked list, in this case we have three cases. So the first case is we are deleting first node from the circle single linked list. Now when we are deleting first node from the circle single linked list, we are just updating the reference of head and updating the last node's reference. So these nodes become eligible for garbage collection. So in this case, this is not time consuming operation. This will take O(1) time complexity. Now when we are deleting a node from the end of circle single linked list, we have to loop through all nodes until we reach the node that is located before the last node. Then we are changing the reference of this node. So this loop will take O(n) time complexity. Now similarly, when we are deleting a node from a circle single linked list at any given location, we have to loop through the nodes until we reach that location. So in the worst case, it will take O(n) time complexity. So if we combine all these three cases over here, the time complexity for deleting a node from circle single linked list takes O(n) time complexity. Now the space complexity is O1 because here we are just deleting one element from the circle single linked list. So that's why the space complexity is O1. Now the last operation is deletion of circle single linked list. Now in this case, when we are deleting circle single linked list, we are just updating head, tail value, and we are just updating the last node's reference. So these operations over here will take O(1) time complexity. So that's why deleting of a circle single linked list takes O(1) time complexity. Now the space complexity is O1 because in this case we are just deleting all nodes from the memory. That's why space complexity is O1. Now with this we have come to the end of this section. So in this section we have learned what is circle single linked list, and we have performed different operations on circle single linked list, and we have implemented them in practice. Then at the end we have learned what is the time and space complexity for this operation that we have performed on circle single linked list. Now in the next section we are going to start another type of linked list, which is double linked list. So see you in the next section.